This is an introduction to integration by parts. Now, integration by parts, we use a formula, which is written here. This formula is derived from the product rule, essentially. In it, what we do is we realize that our integral that we're taking is composed of two parts, a u and a dv. The u is something that we will eventually take the derivative of to produce du over here. And dv is something that we will find an antiderivative for, which is used here and here. Now there are, in my mind, three different versions, or three different reasons for using integration by parts. The first one, like what we have, is when we do a polynomial multiplied by either an exponential function, the sine function, or a cosine function. And in our case, we have the integral is a polynomial multiplied by an exponential function. In these circumstances, often we'll let u be equal to the polynomial, and then dv will be everything else. So, as I said, u is our polynomial, so I'll let u be equal to 5x, and dv will be equal to e to the x dx. To go from u to du, we differentiate. The derivative of u with respect to x is 5. Multiply both sides by dx, we get du dx is 5. Multiply by dx, we get du is equal to 5 dx. Similarly, we're going to integrate e to the x. The antiderivative of e to the x is e to the x. And now, we're going to take our formula. We started off by identifying u and dv, and we're going to multiply u by v, and then subtract another integral. So our job of doing integrals is not complete. We're going to multiply v times du and subtract. So, just to review, here we have u dv is equal to u times v minus the integral of v times du. Now our job isn't done when we do integration by parts. It just produces a new integral for us. With any luck, a simpler integral. In this case, it is simpler. The integral of 5e to the x is 5e to the x. And so we have 5x e to the x minus 5e to the x plus a constant. And if you want to check your work, you can take the derivative of this. Now, if you think about it, this first term will produce two terms using the product rule. The second term only produces one term. It turns out that two of the terms that appear out of those three terms will cancel with each other, and the only term that will remain is the 5x e to the x. Our second example is another one just like this, except that it's going to illustrate that one iteration of integration by parts might not be enough. Here I have once again a polynomial, this time multiplied by the sine of 4x. It also shows how we might have to use integration by substitution, or our knowledge of that in the process. So we'll let u be equal to our polynomial. dv is going to be everything else. We differentiate u. The derivative of 16x squared is 32x. Multiply both sides by dx, and we get 32x dx. Now this is dv, finding the antiderivative of this, is a little bit trickier. We could use substitution, but we could also use a little bit of guesswork because what I'm taking the sine of is not terribly complicated. I would imagine that the integral of the sine would involve negative cosine of 4x, but if you take the derivative of negative cosine of 4x, you're going to get sine of 4x times 4. And so to compensate for that, we multiply by a 1/4 out front. If you can get that skill down when you have the sine, cosine, or an exponential function of a linear function, that might save you some time. So we're going to put things together. We take u times v, and then we subtract integral of v du. So there we have it. U times v minus the integral of v du. A little bit of simplification. And we see that our integral now, we still have a polynomial multiplied by a trig function. So what we'll do is we'll take this and we'll set up a new integration by substitution. Now, we've gotten rid of the u and v, and so it's okay to use them again. Sometimes people are really fussy about using variables more than once. It's okay to do that again. It's okay to do that again. So we'll have u is equal to 8x, my polynomial. dv is everything else. Take the derivative of 8x, we get 8. Multiply both sides by dx, we get du is equal to 8 dx. Now dv is the cosine of 4x. I would guess that the antiderivative of the cosine of 4x would involve the sine of 4x, but the derivative of the sine of 4x would pop out a new 4, so we multiply by 1/4. Now in this new slide, I've just rewritten all of our new information that we have here, plus the integral where we were left off. So I'm going to take u times v, where here we have u times v, and that's going to be 8x times 1/4 sine of 4x, minus the integral of v times du. There's v and du. Simplify a little bit again. When we simplify, we would have 8 times 1/4 is 2. The antiderivative of negative sine of 4x would be 1/4 of the cosine of 4x, but if we multiply the 1/4 by 2, we're going to end up with 2. The final example is the situation, a second type of integration by substitution, or integration by parts, where we have some function here multiplied by one of a few different things. The natural log of x, the inverse tangent of x, or the inverse sine of x. In this case, our only choice is to let this be our value of u. That didn't come out so nice, but that's what it's supposed to say. Because I don't know an antiderivative for any of these three functions, so that's going to have to be u. In our case, u is the natural log of x. dv is everything else, which will include the x to the 3/2 dx. We find the derivative of the natural log of x, multiply by dx, we get 1/x dx. And then we find the antiderivative of v. The antiderivative of v, we would add 1 to the exponent, x to the 5/2, divide by that new exponent, which is the same as multiplying by its reciprocal. We'll piece this together. U times v is going to be 2/5 x to the 5/2 times natural log of x minus the integral of v times du. V is 2/5 x to the 5/2, du is 1/x dx. And this is going to require a little bit of simplification. That's x to the 5/2 divided by x to the first, so we could subtract exponents, which is just going to be x to the 3/2. And I can find the antiderivative of that. Now, ignoring the 2/5 here, the antiderivative of x to the 3/2 we already did up here. It's 2/5 x to the 5/2. When I combine the new 2/5 that I had with the old 2/5, it's going to become 2/5. So the first part stays the same. 2/5 times 2/5 is 4/25, x to the 5/2 plus c.